In this question, we have been given three vectors. The first of them, a bar, is minus 10k cap, and this vector is a constant vector. You can't vary it. The second vector, b bar, is also a constant vector, and it is given to be 5j cap, so that's also a constant. Now the third vector, c bar, is a variable vector, and c bar must satisfy the equation, namely c bar cross b bar plus a bar equals 0 bar. Now the question asks us to find the minimum value of mod c bar which satisfies this particular equation. And so, to simplify the question, I'm going to substitute for b bar and a bar as follows: c bar cross b bar has been given to be 5j cap plus a bar, so that would be minus 10k cap. Now that should be equal to 0 bar. And since I'm interested in finding eventually the minimum magnitude of c bar, I'll try to arrange things in such a way that c bar is on one side of the equation. So to begin with, I write c bar cross 5j bar, and I transpose 10k cap to the right hand side, and what I get is 10 times k cap. Of course, at this point I realize that c bar is multiplied, this is a cross multiplication, with 5j bar, so it's a cross product, and there is no way that I can take 5j cap to the right hand side, because division of one vector by another vector is not defined. So I have to solve the problem retaining 5j cap for some time on the left hand side. And so our objective in this particular question is to find the minimum value of the magnitude of c bar which satisfies this equation. And we will attempt to solve this question using a diagram. Naturally, since the vectors involved 5j cap and 10k cap are along the positive y-axis and the positive z-axis respectively, it is clear that we will begin the solution by drawing an xyz coordinate system, and later on we will show these vectors, and also we will attempt to show the vector c bar in this particular diagram. And so right here we have shown the xyz coordinate system which we intend to use, and this point over here, the intersection of the three axes, the x-axis, the y-axis and the z-axis, that's the origin, and students can verify that the coordinate system which we have shown is a right-handed coordinate system as per the usual convention. So if you curl the fingers of your right hand from the positive x to the positive y-axis and you stretch your thumb, then you can cross check that your thumb points in the positive z direction, and so it's a right-handed coordinate system. Now we will begin by drawing the vector 10k cap in the diagram. Clearly the vector 10k cap points in the positive z direction, and if I show it starting from the origin, which I can of course, the vector 10k cap could be denoted by this directed line segment, and so by the side of it I'll write 10k cap. The next vector which we will show in the diagram is this vector over here, which is 5j cap, and we know that this vector must point in the positive y direction, and if I start it at the origin, then I get a vector as follows, this particular vector, and I will name it 5 times j cap. What remains of course is to show the remaining vector c bar in the diagram, and we now proceed to try and get at least a rough idea of the direction of c bar so that we can then proceed to draw it in the diagram. Remember, by the rules of the cross product, the product 10k bar must be perpendicular to each of these two vectors. So it basically means that 10k cap must be perpendicular to c bar, and simultaneously 10k cap must also be perpendicular to the other vector involved in the cross product, which is 5j cap. Now if 10k cap is perpendicular to both of these vectors, clearly it means that the vector 10k cap must be perpendicular to the plane. Remember, these two vectors c bar and 5j cap, they define a plane. There is a single plane which passes through these two vectors, and since 10k cap is perpendicular to each of these two vectors, 10k cap must also be perpendicular to the plane containing those vectors, that is containing c bar and 5j cap. Try to think of a plane which contains 5j cap and which is perpendicular to this vector 10k cap. If you can imagine that plane, then clearly that plane would also contain the third vector c bar. If you think for a while, probably you would be able to identify that plane. It is nothing but the xy plane, which is the plane containing the x-axis and the y-axis. Clearly the xy plane does contain the vector 5j cap as required, and also the xy plane is perpendicular to 10k cap. Now this would mean that the location of the vector c bar has been found by us to be the xy plane. We have to now draw the vector c bar in this diagram, and we start by drawing it in the xy plane. So as an example, I have shown the vector c bar like this. For convenience, it has been shown starting from the origin. Now you have to use your imagination. It's a 3-dimensional diagram shown on a 2-dimensional computer monitor. So use your imagination. The vector c bar is in the xy plane. The xy plane also contains the vector 5j cap, and the vector 10k cap, which is along the positive z-axis, is perpendicular to the xy plane. You could understand the situation even better if you realize that the angle of 10k cap with 5j cap is 90 degrees, But not only that, the angle which 10 k cap makes with C bar is also 90 degrees. Now remember, I still don't know what is the magnitude of C bar. So I have drawn a line segment of an arbitrary length. We will tackle the magnitude problem later on, but let us first check whether the direction of C bar is correct. Remember, C bar's direction must satisfy the equation C bar cross 5j cap is equal to 10 k cap. This means that we should be able to apply the right hand rule between C bar, the direction of C bar, and the direction of 5j cap, and we should be able to get the direction of 10 k cap. Now let's see whether this is valid. So you have to use your imagination. If you curl the fingers of your right hand, or you imagine that you do that, from the first vector C bar to the second vector 5j cap, in other words, curl the fingers of your right hand in that direction through the smaller angle separating them, and then you stretch your thumb. Clearly, if you do it rightly, then your thumb will point in this direction. In other words, the direction of C bar does satisfy the vector equation C bar cross 5j cap is equal to 10 k cap. So we may have got the direction of C bar right. There is nothing which seems obviously wrong, at least about our assumed direction of C bar. And the same would be true for a direction of C bar chosen to be along this directed line segment. Once again, the right hand rule will be satisfied. That is, if you curl the fingers of the right hand from the chosen direction of C bar to 5j cap, then once again your right thumb, outstretched right thumb, would point in the direction of 10 k cap. So just as this direction is a possible direction for C bar, so also this direction is another possible direction of C bar. Let us remind ourselves once again that here currently we are only talking about the possible directions of C bar, and we are not currently talking about C bar's magnitude. It's quite easy to see that other possible directions of C bar could be this, for example, direction, or maybe this direction, or even maybe this direction, that is along the positive x-axis. Now let's go one step ahead and analyze this particular direction of C bar. Is it a valid direction? Notice that when we curl the fingers of the right hand from C bar to 5j cap through the smaller angle between them, that is through this angle, and we stretch the thumb of our right hand, we notice that the outstretched right thumb once again points in the direction of 10 k cap. Now this would mean that this particular direction of C bar once again fulfills the equation C bar cross 5j cap is equal to 10 k cap. So essentially all of these directions shown by the red arrows, all of them could be possible directions for the vector C bar. Of course, when I draw all of these arrows, I also mean the directions in between the two arrows, like for example this direction, or this direction, or this direction, or this direction, and so on. Now we earlier said that C bar must be a vector in the xy plane, so we can check whether there are any other directions in the xy plane remaining to be investigated. For example, if we go to the other side of phi j cap in the xy plane, that is, if we consider this direction for c bar. Once again, you should recall that this is a three-dimensional diagram. This particular direction of c bar is a direction in the xy plane. Now, does this direction, is this direction acceptable? That is the question. In other words, we want to find whether this direction fulfills this particular equation. So let's apply the right hand rule. If we curl the fingers of our right hand from the vector c bar to the vector 5j cap through the smaller angle between them, basically this angle, and we stretch the thumb of our right hand, with some imagination you will see that c bar cross phi j bar does not point in the positive z direction, rather it points in the negative z direction, like this. So that would be the direction of c bar cross 5j bar. In other words, this particular direction for c bar is unacceptable, and hence I'll just put a cross in front of it. It's an unacceptable direction. Likewise, it can be shown that all of these directions, note that all of them are also to be imagined in the xy plane, all of these directions are equally unacceptable as directions of c bar, because the direction of c bar cross 5j cap for all of these directions is in the negative z direction rather than in the positive z direction as required. I mean, for example, you could consider this direction of c bar. You find the direction of c bar cross 5j bar by curling the fingers of your right hand from c bar to 5j cap through this angle, and stretch the thumb of your right hand, and once again you will see that the outstretched thumb of the right hand points in the negative z direction, which is unacceptable, and hence this particular direction of c bar is also unacceptable. So let us now concentrate on the acceptable directions of c bar. All of these directions are acceptable because they satisfy the equation c bar cross 5j cap is equal to 10k cap. Up till now we have only talked about the direction of c bar. Now let us talk about the magnitude. Remember, the magnitude of c bar cross 5j cap must necessarily be equal to the magnitude of 10k cap, which is nothing but 10 units. But c bar cross 5j cap, the magnitude of c bar cross 5j cap is equal to mod c bar times mod 5j cap times sine of the angle between c bar and 5j cap, which I'll call theta, and this must be equal to 10. If you want to see an illustration of the angle theta in the diagram, you could look at this particular possible direction of c bar. In that case, the angle theta would be this angle. That's angle theta. Notice that on the left hand side, mod of 5j cap is fixed, it's a constant, it's equal to 5. Sin theta is dependent on the chosen direction of c bar. and on the right hand side this 10 is of course a constant. Consider what happens when we change the direction of C bar. Look at all of these possible directions. As you go on changing the direction of C bar, clearly the angle theta goes on changing, and hence sine of theta, this term, changes when you change the direction of C bar. But we notice that when sine theta changes, or even when sine theta changes, the product mod C bar multiplied by 5 multiplied by sine theta should remain a constant, that is 10. This means that whenever sine theta changes because of changing the direction of C bar, we must necessarily change the magnitude of C bar also. In other words, we must adjust the magnitude of C bar such that this product, the product of these three terms, remains constant at 10. And herein lies the crux of this part of the problem. We want to find that value of sine theta so that the modulus of C bar is minimized. Notice from the diagram that theta lies between 0 degrees and 180 degrees. Hence, the value of sine theta will always lie between 0 and 1. This is because as theta goes from 0 to 90 degrees, sine theta changes from 0 to 1, and when theta goes from 90 degrees to 180 degrees, sine theta goes from 1 to 0. Now, to return to the question, we know that we have to minimize mod C bar. Notice that mod C bar multiplied by 5 multiplied by sine theta is a constant, that is 10. When we try to minimize mod C bar, that is when we make it small, we have to compensate for that by making sine theta large, in order that the product of mod C bar and 5 and sine theta remains constant at 10. Clearly, from this particular equation, the minimum value of mod C bar will be attained when the value of sine theta is maximized, and we know that that value, the maximum value of sine theta, is equal to 1. This will of course occur when theta is equal to 90 degrees. Clearly, in the diagram, among all of these possible directions of C bar, it is this particular direction wherein theta is equal to 90 degrees. It is this particular direction which yields the maximum value of sine theta, that is 1, and simultaneously it yields the minimum value of mod C bar, which means that the minimum value of C bar, or rather mod C bar, is obtained when C bar points in this particular direction. So all that now really remains is to find what is this minimum value. For that, I am going to use this equation. I am going to write mod C bar, and since we know it's going to be the minimum value, so I'll write a suffix min multiplied by mod of 5j cap, as explained earlier, is a constant, is equal to 5, and multiplied by the maximum value of sine theta, which is of course sine 90 degrees, which is equal to 1. So I'm going to put here sine of 90 degrees, which is equal to 1, and this of course must equal 10. And if I just simplify this equation, I get the minimum value of mod c bar satisfying the given conditions in the question equals 10 by 5, that is 2, and this particular condition or this particular minimum value of mod c bar is obtained for this particular direction of c bar, namely this occurs when theta is equal to 90 degrees as shown in the diagram.